Hi, it's John here. I just thought perhaps I should give you a bit of a heads up on this spreadsheet we have here for indicating the cost of operating machines on the farm, because it is a little bit complex, I guess. Remember that it's a demonstration only, not a program such as the Landmark Farm program. And it is a demonstration, and any of the data that I actually enter in here is going to be fictional. Perhaps the first thing we should do is have a look at the structure of the spreadsheets. There are three parts to it. If you look down the bottom, we're looking at the powered machinery data entry point. We can then click into the next sheet, and we can start looking at different implements that we're likely to tow behind those machines. And finally, we have combinations where eventually, when we've entered some data, you'll be able to select the machines and the implements they're pulling and follow it through and work out a cost per hour and a cost per acre. Now we'll go back to the powered machinery, which is a good starting point, and I'll enter some data here. Remember, the data is purely fictional. The first thing we need to do is to enter an interest rate or opportunity cost. The opportunity cost is really the difference, the percent interest difference between the next best investment you could make and this investment. It could, of course, be, say, your bank interest. But however, we're using what is actually called opportunity cost, and I'm settling here for about 4%. We can come down and name the vehicle, and we can the machine, and I've done that, and we can just use the arrow keys or the mouse to move around the program, and I'm just going to enter a purchase price in it. As I say, purely fictional. The next thing we want to do is put in a salvage value. We expect the machine to last 10 years. You can always go to your dealer and ask him how much he's trading in a 10-year-old machine for, and work that out as a percentage of the new price for a machine that was bought 10 years ago, if you wanted to do it that way. I'm just sticking in any old figure. I'll stick in 75,000 there. Kilowatts in horsepower, well, I've got a little conversion factor there for horsepower, which is quite a common quotation, but if you want to convert that to kilowatts, which you'll need to do for this example, you multiply it by 0.735. So let's say we've got a machine here with about 88 kilowatts. You'll notice that the opportunity cost has shown up here, and it's flowing through into all machinery based on the figure that you put in at the very beginning. Cost of labour per hour, let's say it's around about $20. Registration per annum, 150, say. The annual insurance, bit of a guess, but it seems to be around about 1% of what you pay for the original machine. R&M as a percentage of cost, that's always an interesting one and a bit controversial. In the old days it used to be 100% of the purchase price of the machine over the life of the machine to maintain it. Nowadays, with machines being just a little bit more reliable than they used to be, you can choose your own figure. Cost of fuel per litre, somebody might have to do a conversion from gallons to litres, but the cost of fuel per litre, let's say, is about $1.5. Annual use in hours, okay, good machine, I'm going to use it 800 hours, this thing here, I think I do. Estimated life in years, well, you'd like to think it'll last 10 years, so you can enter 10 years, and it does the calculation for you, and there you have all of the figures on the right hand side indicating those costs and the cost per hour, and I'm showing that at 87.60. Now I'll just stick in a bit of data for this John Deere tractor over here, and then we'll move on to the implement. And so you can see I've entered data in here now for the John Deere GS series, and we have some figures out here which are showing us that there's a cost of around about $91.68 an hour there. You can have with this spreadsheet here up to 6 different powered machines. So we enter data for those machines if that's what however many you've got, and then we select implements, and these are the implements we're going to tow behind the machine. And so I'm going to enter some data into these areas here, and I'll do that quite quickly so that we don't waste time. So you can see that I've entered a bit of data in there: springtime grubber, combination roller, drill, power harrows, and there is the opportunity to include costings for up to 8 different machines or implements. So once we've entered that data, we can go into the combinations and select the combinations. And now you'll see that some of the machines that we have recorded there are coming through into this matrix that we have before you. If we want to work out some cost for, say, the case tractor, we put a 1 into the powered machinery, and then we'll have a look, and we think, okay, we'll use the springtime grubber and the combination roller there. So you can see now that we have accumulated a cost per hour of operating that combination of gear is $99.01. That's on the information we have, the fictional information I've entered into the program. You can change the combinations around. Maybe you want to use the John Deere tractor, so we just delete that one and go down here and select the John Deere GS Series 1 there, and maybe we'll work with that operation. But you can see that the cost has just gone up a whisker and is now $103.53 based on that fictitious information. Okay, the next thing that we want to do is to go through, and so we've worked out an hourly cost of operating that combination there. So now we're going to enter this area here that's confined within this green boundary, and we need to answer these questions. Estimated or known speed, you could work with this combination. Well, perhaps before we do that, we need to come into this matrix here. First of all, you've got to decide whether you're imperial or metric. So I'm going to go down this this imperial route here. Do you know the acres you would cover in 1 hour with this combination of implements? Now, if you do know, then you can just come along here and follow this decision line down here and use this column of information. And we could pop in here and say, yep, okay, I think I can work here at 5 miles per hour. That's fine. What is the widest working width of this combination in feet? And we'll say that it's 30 feet. Okay, and I've used this combination before, so I do know how many hectares or acres per hour I can work with this. So I think that I can work something like about 15 acres per hour, and I put that in there, and the program calculates the field efficiency in this case here for that machine, and the cost per unit area for this combination. So that's working out at $6.90 per acre for that particular machine, which sounds a little ridiculous, but it still illustrates what I'm trying to say. Now I'm going to stop now, and we'll come down the metric route. So here I am again, and this time I'm going to come down the metric route. Do you know the hectares you would cover in 1 hour with this combination of implements? We'll say no this time. We'll come down and we'll use this column here. We think we can operate this machine here at around about, say, 8 kilometres per hour. And the number of metres that we're covering is probably something like about 12 metres. And then we start to, because we don't know how many hectares we're going to cover, we're going to say that our field efficiency, which takes account of wheel slip and turning and headlands and so forth, we'll say it's about 75% there, and it's come up with a cost of something like $14.38 per hectare. So you can use this tool here by changing your combinations of machinery. Remember, you can have up to 6 different powered machines and up to 8 different implements, and you can just select the combinations and go through this and work out your cost per acre or your cost per hectare. So have some fun.